Okay, so now that we've introduced you to the concept of relativity, or why we need relativity, we're going to start hurting the brain a bit. So we're going to start off with the first concept, simultaneity. And let's set up, again, we're going to set up an experiment. So we have an observer, me, standing there. And if I set up two boxes the same distance apart, then I put little magnesium explosions in there. Magnesium's the classic flash bulb you always see in the old Wild West movies and things. Set off the magnesium flare, there's a bright flash of light, and these send out light waves. Now if these are the same distance apart, and the speed of light's the same, these light waves should turn up simultaneously, and I should see them at the same time. Poof, left and right flash, poof, all at once. But now, let's stick in me, I'm going past in my spaceship. Yay, I like my spaceship. Spaceship good. And I'm going past and using like an Orion Bang Bang, so, which is a type of spaceship. And we don't know, 0.1 speed of light or whatever. Now what happens is that it takes a physical amount of time for the light to get to me. And as this light's approaching me, I'm approaching it. So this means I'm going to see this before I see this, because as I'm going away from this, it takes a physical amount of time for that to catch up, but I'm also going that way, so it takes long. So even though these go off at the same time, for observer 1 sees them at the same time. Me, even if I'm there at that exact same point at the same time, I see them at different times. And the question is, who is right? Who is correct? Because observer A says these went off, boom, same time, you see them same time. Observer B says, even though these went off at the same time, observer B sees something different. Who's right? And the answer is both of them. Because each of these is experiencing time slightly differently than the other. Or is actually experiencing. So every single observer in the universe experiences time differently depending upon their velocity. So Terry, if you're standing on the street and I'm walking towards you, I know we don't do this at the moment due to COVID and all that type of stuff, but if I'm walking towards you, I'm technically experiencing time at a different rate than you are. So just leave that to sink in for a minute. We'll make this a very short video. Next one's going to hurt the brain a lot. But one of the important things is that all observers see things differently. So time is relative. Time for each observer is different. And that is a really important concept in physics.